you, sir?
How are you, sir?
I'm pretty good. I'm pretty good. How are you guys going?
Nice, sir.
Nice,
sir.
Good, good, good. That's good. I can see a lot of smiling faces. That's always a good sign. I might get us started. So, instead of moving straight onto a new topic, we still have a couple of things I wanted to cover on flowers, and pollination and the rest of it. So, what that basically, what I wanted to, go through was in terms of the plants and the structures. There's a bit more detail around certain parts of the plants that I wanted to just run you guys by, just so you've got a deeper understanding of the different parts of the plants itself. So, if you guys remember, before we go on to the flowers, I'm getting ahead of myself. Thank you for those of you who did send your homework through. So about half the class, or just over half, did send it across to me, either through the chat or directly across to myself in WhatsApp. Few people who didn't, which is Prinsika, Dinushan, Satvika, and Rahul. Just please make sure next week onwards that you do send me the homework, okay? Because it's the first week, I'm not going to go or bang on about it. Just from next week onwards, please make sure you do send it before the class on Wednesday evening. Just to run through the homework exercise itself, it was just a fill in the blank. Pretty straightforward in terms of what you had to do. The complex part there might have been where certain words were used twice in the set there, so you just had to work out where they fit. So if we just go from top to bottom, plants grow and change as they get older. That process is called development. Plants go through different stages in their development. These stages fit together from the beginning to the end of the plant's life. The stages go in an order, and all of them in that order form the plant's life cycle. New plants are created from the parent plants through the process of reproduction. There's two types of sex cells that are needed to initiate and create reproduction, which is the ovum and the pollen. New plants are created like their parents, but aren't exactly the same. Remember, we were talking about how they can be dispersed across different environments. So based on the resources available, they change slightly. And for male and female bean plants is a very specific example. They produce new plants, through seeds, like we spoke about last week as well. Did anyone have any questions on the homework activity before I move on?
No, sir.
Perfect.
No, sir.
I have a question.
Hold on, guys. Hold on. Just pop your hand up for me on Zoom. Remember, I can't see who's speaking. Sashwin, yes.
Well,
I can't hear you,
the
mate.
stars for, sir?
Oh, the
What are
stars are the
for?
people that sent me the homework. So the ones that are blank are the people that haven't sent me the homework.
Oh, all right, sir.
Okay, so thank you to Sarwin, Sashwin, Ritishan, Puvarna, and Lokapriya. All of you guys sent it to me before the class this week, so thank you for that one. The other guys, just please make sure next week you send it to me beforehand. Cool.
Okay, sir.
Thank you, guys. Did you need me to explain that for you, or is it clear?
Can you explain it, sir?
Yep, so number 3, right?
No, sir. Number 4 question. The stages go in and end.
Oh, yep.
All of
Okay. So, what word did you have in there for number 4?
all of them. I erased it, sir. I forgot what I put in there.
Okay, that's okay. But basically number 4 is saying there's certain stages, right, in terms of the beginning and end of a plant, and those stages happen in a very specific order. You can't have step 1, then step 4, then step 2, then step 5, right? It has to be in a specific order for the plant to be able to go from the beginning to the end of its life. So those stages occur, and when they happen in that specific order, that whole process is referred to as the life cycle. So there's stages. The stages are in a specific order. That order of stages is the actual life cycle of the plant. Does that make sense?
Yes, sir. If it doesn't have the clear order, it will be changed. It's going to be hard to do that.
Correct, correct. Ritishan, yes, I see your hand.
In the order, we call it life circle, yeah?
Yeah.
Life circle or life cycle?
Cycle. CYCLE, life cycle.
Okay, sir. How about circle? Life circle.
So the diagrams can sometimes be represented in the shape of a circle because it's always continuous, right? But the correct terminology is life cycle.
Okay,
The
sir.
circle is just a shape. So I don't believe there's a term called life circle.
I'm just used to saying life circle. That's why I asked.
Fair enough. So I believe the correct one is life cycle, but in terms of generally how the life cycle is depicted, right, in an illustration, that's in usually the shape of a circle because there's always a start and a finish, but the finish then leads to the start and we go around. Lokapriya, yes?
Me, number 5 is wrong, sir, because I put new plants are made by seeds. This called reproduction.
Okay, that one, yeah, okay, it's a fair call because new plants are created, from seeds. The reason it's parents is because the reproduction occurs within the parent plants, right? So from the anthers, the pollen, and then the ovum within the ovary, that reproduction process happens within the parents, which is why parents slots in there. But you're also correct in the statement. If we weren't talking about reproduction, you can say new plants are formed from seeds.
Yes, sir.
Cool. So let's go in, guys, in a little bit more detail around the structure of flowers as well, right? I wanted to go through each part and give you a description and a bit of an explanation of what they are. So the stamen, which is this section here, refers to 2 parts of the flower, right? You've got the anther and the filament. Now, the filament, which is represented by these green sort of lines, right? They are a stalk which support the anther, which is the yellow piece up here. They are essentially the structural framework which hold the anther in an elevated position within the flower so that it's more accessible to pollinators. So the pollinators being the insects that travel into the flowers, right? We were speaking last week about how there's nectaries or nectar at the bottom of the flower, which can attract different insects. So by these filaments being in place, they lift the anthers up to a more accessible part of the flower so that the insects can interact with them in an easier fashion. Now, the anthers themselves are a sac-like structure, as we said, situated on the top of the filament. Now, within the anther are pollen sacs, which then contain the pollen grains. The pollen grains are what get carried into the stigma and all the way down to the ovary, to the ovum, and are fused together with the ovum to initiate the process of reproduction. Now, carpel, which is this, you can see it here, refers to the female organs, these 4 parts of the flower. The stigma, which is the topmost part, right, this opening here, that is designed to receive the pollen during the pollination process. So from the anther, the pollen grains, the stigma is designed to receive those. And in order to more easily receive those, the stigma can have a sticky structure and interior to try and create that pollen to travel within. Now, the style, which is this part here, that is the tube-like structure which connects the stigma, which is the top part, to the ovary. It also provides the stigma a positioning which is appropriate for pollen reception, right? So by allowing, again, the stigma to be up the top, it creates a greater likelihood of the pollen traveling down the style and across to the ovary. The ovary is the section here, which is the enlarged basal part of the carpel, right? The carpel is that 4 pieces, as we were talking about. So the ovary is right down the bottom here. And inside the ovary, you've got one or more ovules which are present. And each ovule contains an egg cell. When the pollination process occurs, and if it's successful, the ovary can develop into a fruit, which down the track produces seeds, and, you know, continues that life cycle to fertilize and further produce more plants. Any questions before we move on to the other parts of the flower? So in terms of the male organs and the female organs. Ritisha?
The female organs, it's called carpel, right, sir? And
Yeah,
can we also call it a pistil?
which one, sorry?
Pistil.
Could you spell it for me?
P-I-S-T-I-L-L.
Pistol. Let me have a look. I haven't come across that term before, but I'm just checking to make sure for you. Okay, so the pistil refers to the ovule producing part of the flower, which is this section here. So you're right, it's part of the carpel. So the pistil and carpel, very similar, but the pistil is more specific to the ovule section, so the ovary section.
In the ovary, there's like a big ovum, sir. Is it correct?
Yes, correct.
And-
Dinesh? Oh, sorry, yeah.
And
you still
sir,
got- yeah, go ahead.
we call the animals that pollinate flowers, we call them pollinators.
Correct. Yes, definitely. Definitely. So those are all the insects and the rest of the animals that travel into the flower that initiate that process. Absolutely.
Yes, sir.
Did you have anything else, Sarin? That's it?
Yeah.
Cool. Perfect.
No, sir.
Dinishan, yes?
In the ovum, have the like seed, right, sir? Is it seed or what, sir?
No, so the seeds don't happen yet. So the seeds come after this entire process. When the fruit develops, that's when the seeds occur. So in this part here, there's no seeds yet. This is the initial process before the seeds come to life.
Sir, when the process is completed, then the seed will come, right, sir? Until then,
Correct.
there's no seed inside it, right?
Exactly right.
Sure.
Exactly right.
Yes, sir.
Thank you, guys. So I'll just continue on here. So the petals, which is on the outer part of the flower, they can be, or they are often colorful or visually attractive, right? With the intention of attracting insects and other animals. Now, the pollinators, as you guys mentioned just previously, those are the insects, and they get attracted to the flower, because of their shapes, their colors, their smells, whatever that might be. Now, some petals also have certain patterns or markings, which are called nectar guides. Now, these ones exist to specifically guide those pollinators who are interested in the nectar itself. So remember last week we were talking about how there's nectaries at the bottom of the flower, and within the nectary there's nectar, which is the sweet substance. So certain markings on specific flowers can be an indication for specific insects that the nectar can exist in that flower, and so they travel to those specific ones. On the other hand, petals themselves provide some sort of protection for the reproductive organs, which is the male and the female organs that we just spoke about. Now, sepals or sepals, which is the furthermost outer layer of the flower, purely exist to protect the developing flower bud, especially during its early stages, right? So you would have seen, like if you see a bouquet of flowers, some of them will be open where you see the really bright petals, but others you'll see are closed flowers, which are the buds that are green, right? They almost look like they're a continuation of the stem. What you're seeing there is the sepal or sepal, which is there to protect the inner floral structures, right? They essentially maintain the structural integrity, but also prevent water loss from that developing flower bud, right? They help retain moisture because they keep it protected and within themselves. Any questions here before we move on to a different topic?
No, sir.
Loka?
It's
Yes?
like,
Sir, is nectar is like honey, sir, or no?
Similar. It's not the same, but it's very similar. So it's a very sweet liquid that attracts.
Is food for the bees?
sir,
Yep, it can definitely be food for certain insects, right? Like bees, they do consume it as nutrients as well. Definitely.
Okay, sir.
Sorry,
sir.
hold on for me, mate. There's a couple of people with their hands up. Yeah, you want me to explain? So, the sepal, right? So if you look at a bunch of flowers, some of them might be open, others can be closed. Are you following me, Sarin? Have you seen ones where the flowers are like buds? They're closed?
Yes, sir.
Right. And
I've
so
seen some flowers open, some flowers
Yes.
closed.
So with the open ones, they're the developed flowers. They've grown, they're older, they've gone through further stages of the life cycle, whereas the buds, which are the younger ones, are still developing. They're still young. They still don't have the full structure within themselves yet. So during that development phase, the sepal, which is the green part, that encloses them and provides a form of protection while the flower is developing. Once it develops and is fully ready, the flower will open, sepals drop to the bottom, and the rest of the flower is within.
No, I understand, sir.
No worries.
Thank you, sir.
Cool. So now we're going back, guys, to states of matter. Now, I know we covered this a few weeks ago, but on a high level. So again, just delving into it in a little bit more detail. I remember most of you had a pretty good understanding, so I'm hoping we can smash through these slides. So going from a solid to a liquid to a gas, right? So those are the three general states of matter. There's a specific process involved going throughout from one type of matter to another. So I'm just going to start from left to right and see who remembers each one. So can I start with this one? Someone put your hand up for me. Loka, yes? Do you know what that one's called?
Melting, sir. Melting.
Sorry, go again.
Melting, sir. Melting.
Melting? Yes, perfect. This one? Anybody else with their hand up? Let me have a look.
Sashwin, sir.
Hold on, mate. I'll come to you. All right, you yelled your name out. Go for it, Sashwin. What's this one?
That one is evaporation, sir.
Can you go again for me? Sorry.
Can you hear me, sir? Now time?
Yes, that's better. Yes, thank you.
Evaporation, sir.
Yes, evaporation. Exactly right.
So
The
can
next
Siren
one.
tell, sir? Can Siren tell?
Siren, hold on. I'll come to you. I'll come to you. I can see your hand up. Okay, go for it, Siren. What's this one?
Condensation, sir. The
Perfect. Condensation. Exactly right. This one here, Ritishan.
it's freezing, sir.
Freezing. Perfect. Now we're getting into a bit more of the complex ones. What about this one up the top?
Sashwin,
sir.
Hold on. I'll call out someone. I'll call out someone's name. Sashwin, yes.
Sublimation, sir.
Exactly. Bang on. And the bottom
So
one,
can Siren tell, sir? Siren.
yes.
It's dispersion.
Deposition. Correct. Now, I'm going to put you guys one more question. Who has an example for sublimation? Lokapriya, yes?
Is water, sir?
Did you say water?
Yeah.
Yes, so definitely water is can be an example used in sublimation, but do you have a specific example from water?
Siren can tell, sir.
Hold on, mate.
Siren
Hold on, Siren. Hold on. Pop your hand up for me. I'll come to you in a second. Dinishan, I see your hand up.
Can be oil, sir, oil or liquids.
Yeah, liquids. If we can stick to how Loka said water, there's a specific example I'm trying to get out of you guys.
We put the water in the freezer and we check and we put in the bowl. It will be evaporation.
Yeah, so you're referring to these ones here, which is correct. So if you put it in the freezer, it goes from a liquid to a solid. But I'm talking more so about sublimation, right? So to remind you guys, just one sec, Siren, I'll call you on. 1 second. So sublimation, just as a reminder, is the movement from a solid straight to a gas, right? So you're skipping the liquid stage. Siren, yes?
The same thing, sir. It's a conversation between the liquid and the solid and the gas.
Yeah, so we're going from a solid to a gas. So the example would be something like snow or ice changing straight into water vapor.
Sir, you can say also a lava, sir. You can.
Yeah. Loka?
One more is ink. Ink, sir.
Ink.
Yeah.
Yep. I need to check that one. Yeah, okay. So going from what's the solid version of ink? Do you reckon? What are you thinking?
So
which version of?
So can we use lava?
Lava could be one because you've got the coal, right? Developed from lava, which then goes into a liquid, and then into a gas as well, right? As heat goes off.
Because I have heard that you can use also lava because it's a liquid also.
Mm-hmm. Yeah, certainly. Cool. And then we'll go on to the bottom one, which is deposition, guys. So an example of deposition, does anybody know? So from going backwards, so from a gas back to a solid, skipping the liquid phase. So again, using water as the basic. Ritishan?
I know, sir. If you take CO2 and a cloth, the CO2 will be in a small container. And if you put the cloth here and open the CO2, and the CO2 will try to come out, and there'll be dry ice on the cloth. because the pressure of the CO2 is making the cloth freeze.
Bang on. Bang on. So that's I guess an experimental version of what we see day to day, right, in the real world, which is the formation of frost, right, where water vapor changes directly into ice. So just as you said, where the gas, right, the CO2 in the experiment goes from being a gas to a solid, right, in terms of the instant cooling. Similar process where the formation of frost from the air into ice. I can see a few more hands up. Sashwin, you have something to add, mate?
So like Ritisan said, there's ice that is there's a lot of cold air. I think there's a lot of cold air coming out of like a ice. You can make it to a solid. No, you can make it to a disposition.
So deposition, remember, guys, is reverse. So it's not from solid to gas; it's the other way around. So it's from a gas to a solid, where you're skipping that liquid phase. Yes.
Yes, sir. I'm meaning that the ice, the smoke, it contains to a disposition. I have seen it. Someone I have do experiment.
Yep. Cool. Sarwin?
Yes, it's the same thing that they both says. The example of dispersion is when water vapor is the atmosphere changes directly into ice.
Yeah, definitely. Ritishan, I see your hand up.
Can you repeat the sublimation thing? I didn't understand that one.
No problem. So sublimation is the reverse of deposition, right? So it's the movement of an item from its solid form to its gas form. So in the case of water, when we see snow, right, on the mountaintops, when they change into water vapor into the air without, melting and becoming a liquid first, that process is referred to as sublimation. Does that make sense?
Okay, sir. Now that it does make sense.
Okay, cool. Awesome. So moving on to evaporation, right, in terms of a specific process. Now, as you guys all know, water, as an example, can exist in three forms. So you've got your liquid, your gas, and your solid, which is water, water vapor, and ice. Now, it can change from one state to another, as we've discussed quite easily, right? So you can use heat, you can use the cold, and by using those two methods, it can transform from one state to another. Now, when it's just a bit of an example. So when wet things like, for example, your skin or your clothes, when they dry and the water changes from a liquid to a gas, what's that called?
What, sir?
It's called evaporation.
Evaporation.
Yeah. I gave away the answer at the top of the slide. Yes, correct. It is evaporation. Now, condensation, on the other hand, so condensation, right, is the transition from a liquid to a gas. This is when new water vapor travels up in the air, and as it goes higher and higher, the atmosphere becomes colder, right? So, from sea level, if you go 20 kilometers up, it's colder. If you go 100 kilometers up, it's even colder, right? Now, water vapor, as it travels up into the air, the invisible water vapor eventually gets cooled to a point where it forms the visible clouds that we see up in the sky. Now, this goes from being invisible to visible because the transition from a gas to a liquid occurs, right?
sir.
Yes. So condensation was the transition from a gas to a liquid, right? So as air, and this is an example of condensation, right? So when air travels further and further higher into our atmosphere, the atmosphere itself gets colder, which triggers that process of condensation. So in our level, when we look around, we don't see the water vapor because it's invisible. As the water vapor travels higher and higher into our atmosphere, where it becomes a colder environment, the water vapor converts into tiny droplets of water, which make up the clouds that then become visible higher up in the sky. In the two pictures to the right over here, can anyone explain to me what's happening in terms of the condensation process? I see a few hands up. Sorry, yes?
Can Jasmine tell for the second one, sir?
Yep, go for it.
In the second one, there's happening I think I might call it a coke. In the coke, it's coming like a liquid, sir.
Yeah.
Weapon.
So what's causing the liquid formation? What do you think is causing that formation?
I think it's about the gas, sir, and the liquid.
Yeah, so the gas is becoming a liquid. So you're right. The water vapor is becoming droplets of water. What is causing that change?
I think it's concessions to do that. It's making it to like a liquid form.
It is, but hold on, mate. Before I come back to you, I'm just going to get Sashwin to run through this. So the change in the liquid, do you think that's happening, Sashwin, because of a heating or a cooling effect?
Wait, sir.
Take a guess.
Is it cooling, sir? Is it cooling?
It is cooling. So very similar to how when the water vapor travels up in the atmosphere and reaches a colder environment, right? And that change in cooler temperature causes the formation from gas to liquid. It's a similar thing that's happening in the photos, right? So the water vapor in the warm air outside is coming in and touching the cold window or the cold can. So, you were talking about it being a Coke can. So the Coke might have been, in the fridge or whatever it is. And when we leave it outside, when the warm air hits the cold can, that causes the change from a gas to a liquid. And that's when we see the little droplets on the outside of the can. Thank you. Sorry, Loka. Yes, go ahead.
There is window. There have tiny drops of water. I think there is rain.
Rain? Yes, sort of. We were going towards, you're right. It definitely could be. That's a very logical answer. But I was more so referring to in the process of condensation, what's happening?
The tiny drops of water become a liquid.
Yeah. So the vapor becomes drops of water into a liquid. Yes. All right. I'm gonna move on.
Sir?
Yes, Sarwin?
I can't understand about the thing, sir.
The which one?
About the condensation, sir.
Yeah. Okay. So condensation refers to when we're going from water vapor to a liquid, right? And going from a vapor to a liquid, the thing that triggers that change is cooling. So when the environment or the item is cooler, the water vapor becomes a liquid. So for example, if you take a very cold can of Coke and you walk outside in the hot sun, what you'll see happen is around the Coke can, you'll see little beads of water, little droplets form. because what's happening is the air around the can is converting from vapor into a liquid because of the cooling effect from the can itself. Does that make sense?
Yes, it makes sense.
Okay, cool. I'm conscious of time, guys, because we're already 9:45. What I might do is skip through. Oh, there's only one more slide. Okay, we'll go through it quickly. Does anybody know, in terms of water, what's the boiling point of water? We're just going to smash through these. Pop your hand up for me on Zoom if you know the answer. Whoops, I gave it away. So, boiling point of water is 100 degrees Celsius. Melting point of ice. Sarin, do you know the answer for this one?
No, I know the answer for this one. But
That's okay.
what is the?
No worries. That's okay. Ritishan?
I think it is 50 Celsius, sir. 50 degrees
Ooh,
Celsius.
Not quite.
50
Not
or
quite.
60.
It's actually zero. So that's the melting point of ice. So because if it's anything above zero, it will also melt. So you're right. In terms of if it's 50 or 60 degrees, the ice will melt. But the lowest point that it can start melting is zero. If it's -1, hold on. Who's speaking? Guys, put yourself on mute, okay? Put yourself on mute unless I call your name, please. Sarin, can you pop yourself on mute for me? Thank you. Ritishan, sorry, I was just saying, mate, at 50 and 60 degrees, it can melt as well, but the lowest point is zero, okay? Because at -1, it won't melt. Now, okay. This section here is just referring to, through the process of heating, you can also separate certain materials, right? So, for example, if you take salt and water together and you mix them up really well, you might notice that the salt tends to disappear and mix into the water itself. If you take that same solution and put it over a flame, like you see here, and you let it heat up and you let the water evaporate over time, you will actually notice that the salt is left behind. So that just proves how, even though you mixed it in the first instance, the salt never disappeared. It just was hidden and mixed into the liquid itself. Now, guys, we've only got about 9 minutes to go. So just quickly, again, just another fill in the blank for homework next week, okay? So if everyone can just make sure you get that one done for me before the next class. Now, just so you guys know, yes, Satvika? Yes?
Can you send it to group, sir?
Absolutely. I'll put the whole slide deck for you into the chat at the end of the class. And if you just go to slide number 12,
Okay,
you'll
sir.
see the activity, okay?
Okay, sir.
Cool. Now, what I'll do, I'll skip through these ones and let's just go straight into the Kahoot since we don't have much time left. Perfect. I'll start it for you guys now. Here we go. Last question. All right, let's see who the winners are. Third place, we have Loka. Nicely done. Then we've got Sarwin in second, and first place is Ritishan. Well done, well done. And then we've got Dinishan and Sashwin coming in fourth and fifth. Well done, guys. Well done. So a couple of things. You would have noticed this week's Kahoot was a little bit longer. And it's going to be like that going forward because I want to cover both the current week plus the previous week, just so you guys are up to date with, you know, all the content that we're covering and it doesn't get lost as we go week on week. So when you get a chance, guys, throughout the week, you know, we've got the YouTube recordings. We've also got our slide decks, which I'll be uploading to the WhatsApp, following every class. So make sure you go through it, write down any notes. If you've got any questions, feel free to put them on the WhatsApp for me, and I can, answer them for you in the next week's class. So please go through the notes, go through the YouTube videos, and that way you're ready for the Kahoot, which will now cover both weeks, the previous week and the new week, in terms of questions. Okay. Anyone got any questions, any final comments before we close off for the evening? Easy. Done. Thank you, guys. I'll upload our deck to the WhatsApp. And Ritishan, I do have a bit of an explanation for you, mate. Difference between
Homework, yes, sir. Homework.
Yes, homework is on slide 12. Okay.
Okay, sir.
I'll pop that in for you. So just remember to get that one done for me, guys. This time you've got 2 weeks, not just 1 week. Cool. Ritishan, I'll pop in an explanation, mate, on our WhatsApp, difference between pistol and carpal for you, okay? It's very similar but slightly different. I'll put it in there. If that's it, guys, thank you very much. I'll see you in a couple of weeks. Enjoy it.
Thank you, sir.
See ya.
Thank
No
you,
problem.
sir.
Bye.
Thank you, sir.